Hello class, we're going to be looking at some more dimensional analysis problems today. This is from a dimensional analysis practice sheet called A Little Bit of Everything, and it has a little bit of everything. So I'm going to work a problem here, number 7. A football field is 100 yards long. How long is it in centimeters? So we're going from yards to centimeters, and that is from an English Standard Unit to a metric unit. And so I need a conversion that takes me from the English Standard to the metric. And the only one I can remember always offhand is 1 inch equals 254 centimeters. Now, yes, there are a lot of other ones, but I'm not going to memorize them all. I only memorized this one. So I'm going to have to go a little ways, but I can still get there. So I'm starting with my 100 yards of football field, and I'm going to go from yards to inches because I know, and I'll put yards on the bottom so that it cancels, 2 inches, because I know how many inches are in a yard. There are 36 inches in 1 yard. And then I'm going to go from inches to centimeters, because I have that relationship as well. 1 inch is equal to 2.54 centimeters. I have 1 and 2.54. Now I cancel my units. Yards cancel because 1 is on the top, 1 is on the bottom. Inches cancel. And so I'm left with units of centimeters. And I multiply any numbers on the top, divide by any numbers on the bottom. And remember, the ones aren't really going to do anything, so you can ignore them. So 100 times 36 times 2.54, and we don't have to worry about dividing by the ones. So I get a number of 9144. Now I'm going to go with a decimal after that 100 because we know there are actually 100 yards. It's not an estimation of 100 yards in a football field, or at least our American football field. And so I have at least 3 significant figures if I have that decimal after the 100. So that gives me at least 3 significant figures here. That means I'm going to write my 3 significant figures, and that 4 at the end is going to round to a 0. Remember, don't put the decimal afterwards. If you do, then you have 4 significant figures. All right. So that's from English Standard to metric. Let's try one that is a little more involved. I want to look at converting within the metric system. Remember, I like to use a system that keeps you from losing your way with moving the decimal from right to left or whatever. So I want to show you a system that I use instead. So on this problem here, we're converting from 9.4 times 10 to the negative 4th microliters to nanoliters. So we're going from one prefixed unit to another prefixed unit. Okay. Remember, when we do that, we're going to go through the base unit. That's the unit without a prefix. So I start with my original number and unit. And I'm going to write the unit that I'm trying to convert, microliters, on the bottom so it will cancel. And I'm going to go to the base unit, just liters. And then I'm going to go from the base unit liters to the new prefixed unit nanoliters. And the system is the prefixed unit gets a 1, and then you define what that prefix means by the base unit. So 1 times 10 to the micro is negative 6. Nanoliters to liters, prefixed unit nanoliters gets a 1. Nano is 1 times 10 to the negative 9th, and that goes next to the base unit. Canceling our units, microliters cancel, liters cancel. We're left with units of nanoliters. Putting that into the calculator, please remember that since this is scientific notation that we're using here, we must use the scientific notation key on the calculator. So we've got 9.4 4, and we're going to use the exponent, or not the exponent, but rather the scientific notation key. And remember that E represents times 10, and we're going to put in a negative 4, not a minus 4, but use your negative key, the symbol that puts a negative on the number. And we're going to multiply across the top and divide by each thing on the bottom. So we're going to multiply by 1 scientific notation key, negative 6. And then we're going to ignore the ones and divide by 1 scientific notation key, negative 9. So we have 9.4 times 10 to the negative 4th times 1 times 10 to the negative 6 divided by 1 times 10 to the negative 9. And that gives us 0.94 nanoliters. We have two significant figures here, and we have two significant figures here. If you want to put your answer into scientific notation, that is perfectly acceptable, and it would be 9.4 times 10 to the negative 1 nanoliters. All right, let's try double units, units that have a unit in the numerator and in the denominator. This is kind of nice because we have something to fill in this empty space that bothers so many people. So we'll do this one. Convert 1.3 grams per milliliter to kilograms per liter. So we're changing grams to kilograms and milliliters to liters. So again, we start by putting our number and units into our grid. Now the 1.3 gram stays together, and it's per milliliter, so the milliliter goes on the bottom. And if that unit being by itself bothers you, put a 1, because it does actually mean 1.3 grams per 1 milliliter. And we're going to do this in steps, but we're going to keep it all together in one grid. Don't break it up. You'll end up causing yourself more work and more likely to make a mistake. So let's keep it all together, and we're going to change first the grams into kilograms, and we can do that in one step. We can go straight from grams to kilograms. And so the relationship, remember, is the prefix unit gets a 1, and the base unit, you put what that prefix means next to it. So 1 times 10 to the 3rd is kilo, and so 1 kilogram is equal to 1 times 10 to the 3rd grams. And that takes care of our grams. They are now in kilograms like we wanted. Then we change the milliliters, and since milliliters starts out on the bottom, we're going to put milliliters to cancel. It will have to go on the top. So milliliters will go now to liters, and the liters will go on the bottom, which makes sense because we want our units to come out to be kilograms in the numerator and liters in the denominator. So again, our system is 1 goes next to the unit with a prefix, and what that prefix means goes next to the base unit. So milli is 1 times 10 to the negative 3rd. And our units cancel. Milliliters cancel with milliliters. And it doesn't matter that they are spaced apart like this. What matters is that one is on the top and one is on the bottom. And it doesn't matter where along here. So milliliters cancel. Our units that are left over are going to be kilograms divided by liters, which is exactly what we wanted. Now we just multiply across the top and divide by what's on the bottom, and we can ignore these ones. So we've got 1.3 divided by, remember we don't need to worry about multiplying by the ones, divided by 1 scientific notation key 3, divided again, remember this is on the bottom, so we divide by it, 1 scientific notation key negative 3. And so we end up with, nicely, 1.3. Alright, to do it one more time, this time going from 7.5 grams per milliliter to pounds per gallon. That's going to take a little more work because here we're going to have to go from metric units to English Standard units in both cases, on the numerator and in the denominator. Again, don't try to break these problems up, do them all together. So we're going to put our 7.5 grams into our grid per 1 milliliter, and we're going to change grams to pounds. So we need to know how many grams are in a pound, and there are 454 grams in 1 pound. So we can go straight from grams to pounds. We've got 454 grams, 1 pound. And then going from, our grams canceled, so we're now in pounds. Now we're going to deal with the milliliters on the bottom. Again, milliliters will have to go on the top to cancel. And milliliters to gallons. I don't actually know how many milliliters are in a gallon, but I do know that there's 1.06 quarts in 1 liter. So I think I can get there from there. I'm going to have to go from milliliters to liters though, and then I'm going to have to go from liters to quarts, and I do remember that there are 4 quarts in 1 gallon, so I'll use that. Quarts to gallons. And something went wrong because I am definitely, oh, I put these in backwards. Well, there. When your units don't come out right, it certainly is obvious that you've messed up. And what a great example of messing up I just did. Alright, so milliliters to liters. Liters has to go on top to cancel. Quarts will go on the bottom. And then quarts have to go on top. And gallons will go on the bottom. Now I might actually get the units I want to come out. So putting in my numbers, I have prefix gets the 1. 1 times 10 to the negative third for milli. My quarts to liters, it's 1.06 quarts to 1 liter. And then I have 4 quarts in 1 gallon. And let's look at how my units cancel and make sure that I've set this up right. Grams cancel, pounds are left. Milliliters cancel, liters cancel, quarts cancel, and I'm with gallons on the bottom. So my units that end up are pounds per gallon, which, checking to be sure, oh good. Phew. Alright, so now I'm going to multiply across the top and divide by what's on the bottom. 7.5 times, I'm going to ignore the 1, 4. So I have 7.5 times 4 divided by all these numbers that are on the bottom, divided by 454. Divide again by 1, scientific notation key negative 3. Divide again, 1.06. And I'm good because I don't need to divide by the 1. So I end up with 62.33895769. And of course I don't want to write all of these numbers. I look instead to my first number. It has 2 significant figures. So my answer must have 2 significant figures. None of these conversion factors count. Don't look at them to determine significant figures. You look at your original data point, and your answer can't have any more significant figures than that data. So we've got 62. I don't have to worry about rounding up to 2 because 3 is less than 5. Alright, so hopefully my messing up helped you see how you could mess up and correct yourself.